Welcome back to section 2.3, talking about the factor theorem. Now, what the factor theorem says that a polynomial f of x has a factor of x minus k if and only if f of k equals 0. What that's saying is that a polynomial has a given factor that's a binomial of degree 1 if the remainder is 0. And that's all it's saying, is that the remainder is 0. When we go through that synthetic division, we're going to get a remainder of 0. Let's look at some examples on the next page. Now we're going to show that x minus 2 and x plus 3 are factors of this given function. And then we're going to finish factoring it. This is another use of synthetic division and the factors to help us factor a polynomial that we couldn't factor without it. So it doesn't matter which one we're going to do first. I'm going to use x minus 2 first. Order doesn't matter. X minus 2 equals 0, so x equals 2. So on the outside, we put our 2. And on the inside, our coefficients 2, 7, negative 4, negative 27, and negative 18. Nothing was missing. I didn't need any placeholders. So now we do our synthetic division. Bring down the 2. 2 times 2 is 4. When we add, we get an 11. 2 times 11 is 22. When we add, we get 18. Times 2 is 36. When we add, we get a 9. 2 times 9 is 18. And you can see when you add, you get a 0 for our remainder. We just showed it's a factor. Now, when we write this, we can write this in that form we talked about earlier, where our divisor goes on the outside, x minus 2. And our quotient, now remember, this was x to the 4th, so this is x cubed, x squared, x constant, and the remainder of 0. So 2x cubed plus 11x squared plus 18x plus 9. Now we can actually keep factoring this. Now I'm going to use my x plus 3. Set that equal to 0, and x equals negative 3. So on the outside, I'm going to put my negative 3. And on the inside, I'm not going to go back to my original function. I'm going to go back to this slightly smaller function. We're going to keep dividing it. So instead of using the original, I'm going to put 2, 11, 18, and 9. That was my coefficient for x cubed this time. Bring down the 2. Negative 3 times 2 is negative 6. And when we add, we get a 5. Negative 3 times 5 is negative 15. When we add, we get a 3. Negative 3 times 3 is negative 9. And when we add, we get a 0. Once again, remainder of 0, we found a factor. So we have our factor. Our initial was x minus 2. This divisor was x plus 3. Now this is our coefficient for x squared, x constant, remainder. So we have 2x squared plus 5x plus 3. And once we get down to that quadratic, we can factor the quadratic. When you factor that, you get 2x and x. To get that positive 5, we get plus 3 over here and the plus 1 here. So you have x minus 2, x plus 3. Here is all of our factors for f of x. 2 of them we were given, and using synthetic division, we were able to find the other 2. All right, let's go to the next problem. Number 10, we're going to show that x plus 3 is a factor of this quadratic, and then we're going to find the remaining factor, this cubic. So x plus 3 equals 0, x equals negative 3. So negative 3 goes on the outside. Now on the inside, be careful. Our coefficient for x cubed is 1. We're missing x squared, so we need a 0. For x, it's a negative 19, and the constant of negative 30. Bring down the 1. Negative 3 times 1 is negative 3. When we add, we get a negative 3. Negative 3 times negative 3 is 9. When we add, we get a negative 10. Negative 3 times negative 10 is 30. When we add, we get a 0. So we know we found to have a good factor because the remainder is 0. So looking at this, our factors, our divisor was x plus 3, and then this was x cubed, so at the bottom it's x squared, x constant, remainder. So we get x squared minus 3x minus 10. That's our function f of x. So we can factor that quadratic. I'm going to put f of x over here equals, so we have x plus 3. And our factors, x minus 5, x plus 2. And we just factored that cubic polynomial knowing one of our factors. So some uses of that remainder with synthetic division. When you're evaluating a function at a given value, the value of the function, f of k, is whatever the remainder is. When the remainder is 0, k is one of our zeros, so the factor would be x minus k. And when the remainder is 0, we're finding an x-intercept. Like I said, we'll be talking about this a lot. So even though it doesn't make a whole lot of sense the way it's written here, as we keep working with this in the next few sections, it'll make more and more sense. Thank you, and I'll see you in the next video.